So this event is my first of the Atlanta Science Festival 2022. My name is Mesa Salaita. I am one of the founders and Science ATL, which produces the Atlanta Science Festival. And we are really, really excited to have everybody here. We had other events scheduled for today that would have been the first events of the festival, but because of the temperatures, they weren't. So this is, I think, maybe there's one other event that ended up being indoors and beat this one out, but otherwise this is our very first ASF event for 2022. So we're super grateful to have the team from GSU, Astronomy and Physics with us, and we're thankful for you all being here. And I will turn it over to Rachel, who is going to be your guide on this astronomical adventure. So thanks so much for being here, and I will see you at another event, I hope.
Thank you so much. So good morning, everybody. It doesn't seem like I can actually make you, I can make you a host or a co-host, but I unfortunately cannot make you a participant. So you get to stay and look with us. But good morning, everybody. My name is Rachel. I am, hold on, I can tell you exactly. 55 days away from being Dr. Rachel, and I currently study supermassive black holes in the center of galaxies that are actively eating materials, and I will be your tour through the nighttime sky. We have two other awesome people here with us today, Dr. Megan Connors and Andrew Caparis, who is another graduate student, and they will be handling the chat and the Q&A. So the way that we want you to utilize these two things, I will be asking some questions to you to participate. And unfortunately, since we can't all be in the same room and I can't hear you all, if you could put those answers to questions I ask into the chat. And then if you have questions about things that I'm saying or things that you're just curious about space and the universe, you can put those into the Q&A. So in our chat option, my first question is, do you guys want to start with a star talk, or do you want to start talking about aliens? So go ahead and fill in the chat with your choice, and we will go with the majority.
I see star talk, aliens, stars, aliens.
So it looks like
Star has it right
winning.
now.
So we're going to go ahead and start with our star talk. So let's bring up our daytime sky here. And this is what it would look like if there was not a bunch of buildings and roads and cars in Atlanta. But this right now is very boring because we can currently see one star in the sky. So let's go ahead and we will fast forward time and set the sun to about 8 p.m. tonight. And if we were in really good dark sky viewing conditions, this would be fairly similar to what we would be able to see. I do have some of the deep sky objects that you would need a telescope to see, but that's the benefit of having a virtual sky, is that you can see all of these things. Now, I always like to start my star talks asking a question. And my first question is, what are these? We have a constellation in the chat, a couple more constellations in the chat. So when we think of constellations, we typically think of things that look like this, but what we're actually looking at when we see these stick figures are things called asterisms, or just patterns that we see in the night sky. And this is where mythology comes in, because like Orion here is supposed to be a hunter. And so they think of things that probably look more like this, where you have hunters and unicorns and many-headed snakes hanging out in your nighttime sky. But when astronomers think about constellations, we think about things that look like this. And the same way that the United States is split up into 50 states, our nighttime sky is split up into 88 constellations. And these constellations were decided on in 1922. And this is when we say something is in the constellation, it'd be like saying something is in the state of Georgia, that it lives inside of a boundary that we put up in our nighttime sky. Now, I actually prefer to start my star talks in the north. So we're going to go ahead and give us a spin. So we're facing north. And the nice thing about the northern sky where we are on Earth is that our northern sky is very consistent. We're always going to be able to go out and see these constellations any time of the year. And the first is probably somebody that is very recognizable to you. It is this collection of stars right here, where you have these four making a bowl and then a handle. Does anybody recognize this set of stars here? That is, I see a Big Dipper, and that is our Big Dipper, which is actually part of a larger constellation called Ursa Major, which is the Big Bear. So the handle of the Dipper is actually the tail of the bear, and then you have its body, its nose, and its little feet hanging out over here. Now, the Big Dipper is really important when people used to use this for navigating through the nighttime sky. So you can actually use the front two stars of the Dipper here. You can draw a straight line, and you run into this star right here called Polaris, which if we go down to our map, you can see is right over the cardinal direction north. So this is our North Star right now. But the funny thing about Earth is while we know it spins on its axis, it also wobbles while it's spinning. So if you think about if you've ever spun a top, and if the top starts slowing down a little bit, it may do this. And basically the Earth is doing that. So while Polaris is our North Star right now, on human time scales, who the North Star is changes. So if we were to go back in time to when the pyramids were being built in Egypt, the North Star was actually, let me put my stick figures back up again, part of the constellation of Draco the dragon. So Draco's head is actually below the horizon right now, and his long body. And it was actually this star right here called Thuban, that when the pyramids were being built in Egypt about 5,000 years ago, Thuban was the North Star. So from, 3000 BCE to today, the axis of the Earth's North Pole has shifted from here all the way over to here. And in about 20,000 years, it will work its way back around and Thuban will get to be the North Star again. But this whole group of stars living in this area here get to take turns being North Stars, depending on how the Earth has precessed on its axis. My other favorite thing that you can see in your northern sky is Cassiopeia, which is shaped like a W here. And the constellation names that we have today are mostly based off of Greek mythology. So Cassiopeia was a queen in ancient times who thought she was very beautiful. So let's put our stick figures back up. And she had a daughter named Andromeda, who she also thought was very beautiful. And unfortunately, she wasn't the best mom. So after she bragged about how beautiful she and her daughter were to some sea nymphs who went and told Poseidon what she had said, Poseidon sent a sea monster to eat them. And instead of, yes, this is a good story. Instead of being like, oh, no, I was a jerk and I was bragging about stuff, I should take a punishment. Instead, she decided to chain Andromeda, her daughter, to a rock to get eaten by Cetus the sea monster. Fortunately, Perseus had just finished slaying Medusa. You can see her head in a basket right here. Perseus came and saved Andromeda, and as a punishment for not being a very good mom and bragging a lot, Cassiopeia got chained to her throne and spends part of the night hanging upside down in the nighttime skies. You can see her arms kind of up like, wah! But the reason, besides the fun mythology with that, the other reason that I like Cassiopeia is because there's one thing in the nighttime sky that with just our eyes, we can see that lives outside of the Milky Way. All of the stars that we're seeing, all of these little nebula that we're seeing, all of those live inside of the Milky Way. But there's one object with just our eyes that we can see that's outside of our galaxy. So let me put our stick figures up again. That W shape of Cassiopeia, you're going to look for the pointier part of the W, and you're going to draw a straight line to this little fuzz ball right over here. And that little fuzz ball is the Andromeda galaxy. So if we magnify it and take a look, and this is our closest large neighbor galaxy. And the fun thing about studying things in space, are you going to listen? There we go. Is it's almost like using a time machine because the light that leaves this galaxy has to travel across the universe and reach our eyes here on Earth. So if we were to go outside tonight and take a look at Andromeda, the constellations were identified by the International Astronomical Union, which still exists today. That's a really good question, Wanda. Thank you. But if we were to go outside and look at Andromeda today, that light took 2.5 million years to travel from Andromeda and reach our eyes here on Earth. So we're seeing Andromeda not the way that it looks right now today, we're seeing Andromeda the way that it looked 2.5 million years ago. And so if space wasn't already kind of cool, the fact that you get to time travel when you look at these sorts of things, I think makes it even better. let's go ahead and we'll zoom back out. And I think that's everybody that I want to show you in the northern sky. So let's go ahead and spin ourselves around. And we're going to spend the rest of the star talk in the southern and southwestern part of the sky. And this is actually my absolute favorite nighttime sky in the northern hemisphere, because everything that you could possibly want to know about stellar evolution and how stars live their lives happens in this region. And we're going to focus on our good friend Orion, who's right here in the middle, hanging out in the southwest. And he's very identifiable because he has those 3 stars that make up his belt. He has this bright red star, Betelgeuse, that if you look at the pictures, his arm is usually up holding a sword. So that's actually in his armpit. And then he has a blue star called Rigel in his foot. So starting with Orion, we can actually start with how stars are formed by zooming in on the Orion Nebula, which is in the belt of, or in the sword. So you have a belt up here and you have a sword down here. And this Orion Nebula is one of the places that we actually were able to see with Hubble Space Telescope, baby stars being born. So you have stars that are still surrounded by their little protoplanetary disks, where they have started eating up that information, collapsing in on themselves and becoming a star. So the thing a star has to do in order to be a star is it has to be gravitationally bound to itself, and it has to fuse hydrogen in its core. And this is the difference between a brown dwarf or a planet like Jupiter, because people like to say Jupiter is a failed star. Jupiter is way too small to be a failed star. Jupiter is just a gas giant. And I shouldn't say just a gas giant, because Jupiter is a great gas giant, but Jupiter had no potential in its life to ever be a star. But these objects here in the Orion Nebula are massive enough that when they collapse in on themselves, they get dense enough that they're able to start turning hydrogen into helium. And that is something that a star has to do to be considered a star. So when, as I like to say, when gas and dust and gravity love each other very much, this is where baby stars come from. And once you have these baby stars, let's zoom back out, you actually have stars of different colors. And the fun thing about Orion is that if you go out and look at it, Betelgeuse is red and looks red in the nighttime sky. Rigel is blue and looks blue in the nighttime sky. Now in the chat, if you have, does anybody have an idea about why we see stars having different colors? I just saw, yes, temperature. Awesome job, guys. It definitely has to do with temperature. So we can see this thing on Earth. If you've ever gone camping and had a campfire, if you look at the top of the fire where it's not quite as hot, it's more of a reddy orange color. But if you look down at the base of the fire where it's burning on the logs, it's very white or blue in color. And that's what we're seeing when we see different colors in stars. You have stars like Betelgeuse, who are red and are more cool. And you have stars like Rigel that are very blue and very, very hot. So it's kind of cool that just with our eyes, we can get some kind of idea of what these stars are doing just by looking at their colors. And the fun thing about Betelgeuse is that Betelgeuse is the color that it is because it's a red supergiant. So it's getting ready to end its life. And this happens when stars have burned up all of their hydrogen and turned it into helium. And then they start burning heavier metals. Like they start, because for astronomers, anything that's not hydrogen or helium is considered a metal. And yes, Andrew actually does a little bit of work with stars. So for me, since I study black holes, stars are kind of like kibble, you know, for black holes to eat. But for people like Andrew who love stars, stars are very important and are very, very cool.
They're the most common food.
It's true. I call them kibble, but it's because especially the small red stars that Andrew studies are the stars that make up the majority of the stars in the universe. So just like finding a pebble outside is a very common thing, finding a M dwarf, which is a small red star like Andrew studies, are also very common things in the universe. But for big stars like Betelgeuse, when it ends its life, it will get to do something exciting. And that's what it's doing right now, where it has started exhausting its hydrogen, has started burning these heavier elements, and eventually it will go supernova. And depending on its mass will depend on what it becomes. And one of the options for what Betelgeuse could become, we can actually find over in Taurus. So going from Orion, we can take the belt and we can go off in this direction and run into this red colored star here. And this star is called Aldebaran, which is one of the eyes of Taurus the bull. And so here's an eye, there's an eye, here's his snout. And then he has two horns that go up like this. And I'm gonna cheat a little bit, not carb, crab. In between the two horns, you have the Crab Nebula. And if we magnify into that, this is the remnant of a star that exploded that we saw on Earth in 1056. And this explosion was so bright when we saw it, it was visible in the daytime as well as at night for several weeks after it exploded. And living in the center of this explosion is a neutron star. So, well, I do love black holes. I first started doing astronomy research on neutron stars, which think about something that is 1.5 times the mass of the sun, but could fit in downtown Atlanta. And that's what you're dealing with when you're dealing with a neutron star. And so that's what's living here. And these objects, because they conserve their angular momentum or how they spin, this particular neutron star spins about 30 times in 1 second. So again, something 1.5 times the mass of the sun that could fit in downtown Atlanta is now spinning 30 times in 1 second. So black holes are great. Everybody also should be on team neutron star. So zooming back out from,
if I could interrupt, how do we know that that happened in 1057, Rachel?
Because there were astronomers in China who were taking records. So astronomy has all over the world has always been very important. So a lot of the historical events that we know of, some do come from Europe, but a lot of them end up coming from Asia and from the Middle East. And so people were very interested in astronomy since forever. And so we're very good about keeping records of supernova that they saw in the sky, although at the time they didn't really know what they were. When they saw comets, and this is one way that we know when comets were coming back around, because comets typically have orbits where they come in, they go back out, they come back in, they go back out. And people historically have been keeping track of this stuff for centuries. And so that is how we know, Andrew. Thank you. That was a very good question. Now, since we're in Taurus, I kind of skipped a little bit. I went from baby stars being born in the Orion Nebula to the Crab Nebula, where a stellar remnant is. But on the back of Taurus are the Pleiades. And let's zoom in on them. And this is the in-between phase. These are the toddler stars. These are very young stars that are only a few 100 million years old. And the cool thing about stars is that they typically are not born by themselves. They typically are born in a gas cloud with other stars. And then as they grow up and live their lives, they may stay together, they may move apart from each other, but they grow up in groups. And the sun is a little bit weird because we don't actually know who the sun's sibling stars are. And that is kind of an interesting thing, because when we look at where stars are being born, they're born in groups. And so the fact that we don't know who the sun's sibling stars are is a little bit strange. So zooming back out from here, so we have stars being born in Orion, we have toddler stars on the back of Taurus, we have middle-aged stars like, yes, Subaru, that is a really good quote. So, or a really good point. So let me zoom in on these guys again. If you've not seen the Pleiades in the nighttime sky, you very well may have seen them if you've ever seen the logo for Subaru. So Subaru is the Japanese name. Yes, and so human timescales and astronomical timescales are very different things. For us, a million years is such a long time, but for things in space, it's like, you know, like I said, these are a few million years old and are only considered to be toddlers. Because our own sun is 4.5 billion years old and our sun is middle-aged. So the sun has probably another 3-ish billion years to go before it starts ending its life. But yes, if you've ever seen a Subaru logo, that is this group of stars right here. That's such a good point. Now that we've talked a little bit about stellar evolution, what other bright stars can we see? Because while this is a really nice sky, this isn't necessarily what you will see in Atlanta because of light pollution. We have cars, we have street lights, we have building lights, but using Orion and his belt, you can actually find this set of stars even with light pollution in the city. So if we take the belt, and again, if we go off to the right, we run into Aldebaran. And if we go off to the left, we run into Sirius here, who's in Canis Major. So Sirius is actually the nose of Canis Major, and he has two little ears here, and his paws are down here, and his back is over here. But Sirius is the brightest star that we can see in our nighttime sky. A lot of times people think Polaris, our North Star, is the brightest star. It's on the list of top 50 brightest stars. It's number 50. But Sirius, on the other hand, is in fact our brightest star. And if you've ever seen something in the wintertime towards the southern sky that seems to be twinkling in rainbow colors, is the moon a star? That's a really good question. The moon is not a star. It is a natural satellite. So when the Earth was a baby Earth, it's thought that a really, really big object impacted the Earth when it was still kind of molten and cooling off and knocked off a piece of material that ended up clumping together and forming the moon. That is a really good question. So,
And note, the moon does reflect starlight, though, from the
Yes.
sun.
yes. Just like every other planet. So planets don't make their own light. Everything that when we see Venus, when we see Jupiter, when we see Saturn, that is all sunlight being reflected off of those planets. But so back to Sirius, if you've ever seen a twinkling rainbow looking object in the southern sky in the wintertime, you probably are not looking at a UFO, you are looking at Sirius. And that's because it's so bright that when its light hits the atmosphere, because you have water molecules and things in the atmosphere, and I think you guys can see me, but basically when that starlight hits the Earth's atmosphere does this to it. And so that's why stars look like they're twinkling, because those point sources of light, when that light hits the Earth's atmosphere, it gets disturbed by the atmosphere. And so you're not seeing aliens if you see a bright twinkling rainbow looking thing in the southern sky in the wintertime. You probably are just looking at Sirius. So from Sirius, we can kind of do a half circle to find some other bright stars in our nighttime sky. So we have Sirius, we go up and we see Procyon, who's part of Canis Minor, the little dog. The light from Sirius is about 8 years old. So if anybody in the audience is 8 years old, Sirius is your birthday star this year, meaning that on the day you were born, the light that left Sirius finally got here on your 8th birthday today. So Procyon, who's in Canis Minor, the little dog, which I'm guessing it must be a hot dog, because it's literally, when you draw the stick figure, it's just these two stars. That's what they mean by little dog. And then from Procyon, you can go up again to Pollux and Castor, who are in Gemini, the twins, and then complete one more little jump to Capella, which is in Auriga, the charioteer. So this group of stars here are all stars that you're going to be able to see in your nighttime sky. And I'll show you that in just a minute. Now I'm trying to keep things half and half. So the last thing I want to show you all is that unfortunately tonight, if you were to go outside, no planets are up at night, right? In the nighttime right now. They're all up in the very early morning. So let's go ahead and we will fast forward time to tomorrow morning. We don't want to, we'll do 6 a.m. I think. Maybe we'll do 6:30. Not 7:30, 6:30. There we go. And if you look over in the southeast, you're going to see this very, very, very bright object here, and that is Venus. So 2 planets are out right before sunrise right now. The first is Venus. And besides the sun and the moon, Venus is the brightest object, while Sirius is the brightest star we can see in the nighttime sky. Venus, besides the moon, is the brightest not star object we can see in our nighttime sky. And then hanging out just below Venus is this little red object right here. Does anybody have a guess about what planet this might be? Oh, so let's see.
So the oldest star, I can actually answer that one while we get some answers for the planets, maybe. The oldest stars are the lower mass ones, which are the ones that I study. And typically, because those are so small and faint, they're actually very hard to see, and you can't see any of them with your naked eye unless you have binoculars or a telescope. However, sometimes, as I learned recently, the nearest star, Proxima Centauri, which is a very old star, can flare and become a naked eye star. So it does this about once a day, where it will get these huge eruptions and get incredibly bright. And so that would probably be one of the oldest stars you could see with just your eye if you happen to catch it at just the right time.
Thanks, Andrew. That's a really good point. And that's, I guess, if we want to talk a little more about stellar evolution, you would think that big stars live a long time and little stars don't. It's actually the opposite. So if you are a very big, bright star, your life is going to be significantly shorter than a star that's like the sun or a star that's smaller than the sun. So as far as, yeah, I'm glad that you could answer that question, Andrew, because I can think about some distant stars that we can see. But so like there's a star in the summertime sky that we can see that's over 3,000 light years away. So that starlight had to travel 3,000 years to get here, but it's still in our galaxy. But as far as the ages, yeah, I'm really glad you were here to answer that. I didn't know that, Andrew, so thank you. I learned something today too, guys. So back to this planet, I saw some Jupiters. Jupiter will be a little bit brighter than that. Uranus, you need a telescope to see, but I see that somebody did, in fact, answer Mars. So let's go ahead and we will zoom in and take a look at Mars. So here we are leaving the Earth's atmosphere. And the other thing that we're going to show when we do this little trip is that space travel actually would be really kind of boring because there's a lot of empty space. It's not like in science fiction movies where you're weaving and dodging and trying to get around stuff. There's a lot of nothing in between the objects that we would go and we would see. All right, so here is Mars. And to get an idea of what size Mars is, you can see this canyon right here, which is called the Mariner Valley. And the Mariner Valley, if we were to pick up the United States and set the United States on Mars, the United States would stretch across this canyon. So that's kind of to give you an idea of how big this is. And Mars has two moons called Phobos and Deimos. Oh, where are you at, Deimos? Are you hiding behind Mars? Oh, there you are. You were just off the screen. Let me zoom out just a little. There's Deimos. So Phobos and Deimos. And if you want a little more mythology, Mars is the god of war in Roman mythology, and Phobos and Deimos are fear and panic. So it makes sense that the moons of the god of war would be called fear and panic. And so Mars is about half the diameter of the Earth. So if you were to measure across the middle of the Earth, you could basically fit 2 Marses across Earth. Does Mars have any water? Let's save that for just a little bit, because we'll talk about that when we actually talk about aliens. Why doesn't Earth's moon have a name? Because the scientists are really bad at naming things. I get very upset about this too, because all of these other moons are named after mythology, or in stories like the moons of Uranus are named after characters from Shakespeare stories. And our moon is just called the moon. I mean, I think that typically happens when things are discovered first, right? So
it does technically have the Luna, like earlier version of the name.
Just means moon.
Yes, it does. But I like to think of its name as Luna.
Yeah. So if you grow up and become a scientist, you should become very good at naming things and make sure they have good names, because obviously we're very bad at it.
But I think it's because our moon was the first moon that we knew about, right?
Yeah, so it's just like the galaxy. Our galaxy is called the Milky Way, but in scientific papers, when you refer to it as the galaxy, because it's our galaxy. And Andrew, we do not count Pluto as a planet because it's a dwarf planet. And why is Mars red? This is a really good question. Mars looks red to us because there is basically rust, iron oxide on the surface of Mars, which looks red. Yep. Yeah, that rusted metal, that's exactly right. So the iron oxide on the surface of Mars is what gives it its red color. Okay, so I think that's everything I want to show you guys in the nighttime sky. So let's go ahead and close out of that. And I want to show you one of the documents that we gave you guys was your own. Now that we've kind of shown you some things that are in the night sky, you can go out and see if you can find them as well. So this has some tools that you can use to plan. So Pluto is still a very hot topic about whether or not it's a planet. I think that Pluto should be proud because it is basically the leader of the dwarf planets. So it's still a planet, it's just a different kind of planet. And I feel like if we're going to be sad for somebody, the person who we should be, or the planet that we should be sad of or for is Ceres, who is one of the dwarf planets that lives in the asteroid belt. And when it was first discovered, it was considered to be a planet. And then it got reclassified as an asteroid until Pluto became a dwarf planet. And they're like, oh yeah, Ceres is a dwarf planet too. So I feel like if we want to be sad for somebody, we should be sad for Ceres, because it had to go from being a planet to an asteroid. And I feel like that's way worse than just being a different kind of planet. The Planet X or Planet 9. That is a really good and hotly debated topic. I feel like, I don't know, Andrew, do you have feelings about this?
So I actually know a tiny bit about this, because there has been to illustrate that we don't know everything about the solar system. We actually don't know, and there has been new results recently that say maybe.
Yeah.
We're kind of not sure. This is ongoing science. There's people right now, observational astronomers using telescopes, trying to find a potential planet X, or a ninth or 10th planet, depending on how you want to look at it.
Yeah.
And so there are people trying to discover that right now. It's ongoing research, actually.
Yeah, Mike Brown, who, if you want to hear the story about Pluto being reclassified, he wrote a book called, I think it's called How I Killed Pluto and Why It Had It Coming.
I think that's right, yes.
So that is a little
I'll put
bit
a link in the chat
about the history of that. And as far as rogue planets in our solar system, that is a really good question, because there are things like with this planet X, we just don't know. And so it's the outer parts of the solar system, like the Oort cloud, we just are not sure what's out there. And so maybe, and also, you know, whether or not Pluto is considered a planet, there are thought to be a lot of things like Pluto that live out in the Oort cloud. So if we wanted to consider Pluto a planet, well, then that probably means there's a lot more planets out there. Could there have been another planet between some of the existing planets and that either merged and as part of the other planets today? Maybe, because there are actually two models that talk about how the solar system formed. And so we don't actually, because we can only see things the way that they are right now, we don't actually know if there was something. And the fact that bodies interact with each other. So my favorite object in the solar system is Triton, which is the biggest moon of Neptune, but it actually wasn't to be a moon. It was an object like Pluto, but it wandered in too close. And mathematically, based on what Triton's orbit is like now, it was expected that Triton had a companion object. And when those three bodies, Neptune, Triton, and Triton's companion, interacted with each other, Triton's companion got thrown away somewhere, and we don't know where. And so it is very possible that early in the solar system, there were other bodies that, based on how gravity was interacting, that things got ejected from the solar system. What happens if a planet dies? Not sure how you mean by that. So, thinking about the evolution of the sun, a planet like Mercury, when the sun starts expanding, when it starts getting ready to end its life, Mercury will get kind of eaten up in that. So Mercury will not be there anymore. Venus also probably will not make it outside of that. Earth is kind of on the boundary. So what might happen to us is that as the sun expands, all of our atmosphere gets blown away by the solar winds, and it just becomes a very barren, cold rock. Yeah.
Yep, because there's actually radioactivity inside the core of the Earth, and that's what keeps it warm and keeps the core of the Earth molten, which gives us the magnetic field that protects us. But over time, that starts to decay. You run out of that radioactivity and you lose heat. And so it just slowly kind of cools down. And so you get a colder and colder rock over time, basically.
Yeah, the sun is getting hotter and bigger. So the question about life on other planets, we'll talk about in just a moment.
Yeah, we've got one more too here. So could the moon be ejected from Earth's gravitational pull, Rachel? Because it is slowly moving away a few centimeters per year.
So I would not say ejected. because to me, ejection means that it's like, okay, bye. And that is definitely not what the moon is doing.
Then
And
we had a
also-
follow-up. Sorry, go ahead.
Oh, I was going to say also, I think that at the rate the moon is moving away, the expansion of the sun is going to be a problem before the moon could get far enough away.
Yep, we'll all get gobbled up by the sun probably before it becomes an issue.
Right.
If the planet turns cold and it's decaying like that, would it still be considered a planet, Rachel?
Well, so the qualifications of what makes a planet have nothing to do with whether it has a radioactive core, whether it has moons or life on it. It has to do with the fact that it has gravitationally pulled itself together and has cleared out its orbit so that it is the thing that lives in that orbit. So even if the Earth were to, like that, if the magnetic field were to die and the sun were to blast away all of the atmosphere, technically by the definition of a planet, as long as nothing else came and dominated our orbit, it would still be a planet. Okay. Oh, goodness. Okay, we're at 11:38. We still have one more thing, a whole other thing to talk about. So we can talk about aliens. So let me go through this really quick with you guys. So basically, it is your own little what's up checklist where you can look at the moon, figure out what stars and planets you see, different colors that you see in stars. It also has little finding charts where it shows you some of the star names of the Big Dipper and how to find Polaris. And also without a black background, and then how to find all of the friends of Betelgeuse, where you go over and you find Aldebaran, the Pleiades, and then when you go from Sirius to Procyon, Pollux, Castor, and Capella. And then we also included an activity on here about how to make a planisphere, which is an instrument that you can use to figure out what constellations are in the nighttime sky. So you should have had all of that sent to you in an email. So that is definitely, I hope that we've prepared you that you could go and look for objects in the night sky. So now we're going to talk about life and the universe. So my first question for you guys is, what is life, or what has to happen for something to be considered to be alive? So I'll have you guys go ahead, if you have answers, put them in the chat so Andrew and I can see them. Oh. And while you're thinking about that, how do the northern lights happen? So the Earth has a magnetic field, and when charged particles from the sun hit that magnetic field, they spiral down and they emit light when they do that. So it's electronics and, or not electronics, it is magnetic fields and charges. Let's see. Objects, yep, and aurora. So we call them northern lights on planets. Their scientific name are aurora, and we see them happening on Jupiter and on other planets too. So let's see. We have to
So it has to have a heart.
A heart.
Has to have water,
Mhm.
eat and move. That's good. You need movement. Water
Carbon,
and sunlight.
hydrogen, oxygen, food, reproduction. All right.
Reproduction, yeah.
Let's look at what life on Earth is like. So somebody mentioned carbon, and so organic materials are what we need here on Earth. And then those carbon atoms end up coming together and making more complex molecules. And life on Earth is based on like DNA, where our genetic code or other things genetic codes are stored. And we're very good about classifying life by this system here, where they have a domain, a kingdom, a phylum, a class, an order, a family, a genus, and a species. So because I love cats, I decided to pick a cat as my example of this. So it is part of the eukarya domain in the animal kingdom, where they have spinal cords, they're mammals, they're carnivores, and they're cats. Yes, kitties are so good. So, but every living thing on Earth falls into something where it can be classified like this. Now, this next question was kind of what some of you were answering. What do things need to be, or do we need to be alive? So we saw that, you know, being able to breathe, having water, and some energy, raw materials, perfect. So we need energy, which we get from the sun. We need raw materials like the hydrogen and carbon and oxygen, things that make water, things that make our bodies. We need liquid water. And this is what humans need, but there are creatures that aren't quite as delicate as we are. Humans, we do pretty good for ourselves, but we also aren't very good in really extreme conditions. We don't like radiation, we don't like it too hot, we don't like it too cold, we need food, we need water. But there are objects called extremophiles that can live in these really strange environments. So you have objects that like acid, objects that like radiation, objects that like it to be hot, objects that like it to be dry. And so when we think about these extremophiles, some of them are very weird, but some of them are also very common. So one extremophile that you may have seen in person, if depending on where you live or you've gone on vacation, are cacti. So if you've seen a cactus, you have seen an extremophile. Because cactuses can live in really arid, dry environments, and the way that their skin, I don't know is the right word, but the way that they have stoma on their surfaces that can close to keep water from being evaporated from being in dry climates. And some species, yes, so you have an extremophile in your house if you have a cactus in your house. And some species of cactuses can go 10 years without having any water. Now we can get a little more weird by going to the depths of the ocean, and there's an object or an animal called a pompey worm that live in these hydrothermal vents very, very deep in the ocean. And so not only can they deal with pressure, they can also deal with temperatures of over 100 degrees Fahrenheit. Some of them can live in boiling conditions, so over 212 degrees Fahrenheit for extended periods of time. Not so much the boiling, but where it's like 150 degrees, which for us would burn our skin. These guys are completely okay. And then tardigrades. I see you guys talking about them. Tardigrades are the extremophile champions. They are polyextremophiles, meaning that they can live in high temperatures, they can live in low temperatures, they can live in pressure, they don't care about radiation, they can live in a vacuum, they don't need to eat. And they look like little water bears. So they're pretty cute and also really tough. They can live in space. Yeah, so tardigrades can basically, they don't care. They're like, give me a rough condition, I'll be fine. And also they're very cute. So thinking about, I wanted to bring up polyextremophiles because one of the other activities we have for you is thinking about alien life other places. So thinking about people that we know, about creatures that we know that can live in these kinds of environments can hopefully give you some ideas when you think about aliens that might live on exoplanets. So thinking about life outside of Earth, because as far as we know, Earth is the only place that is like Earth. We hope that it's not, but as far as we know, this is the only place that is like Earth. So where else could we find life like us? Organic molecules are what make us up. We talked about that at the very beginning, and they're found on meteorites from the beginning of the solar system. And they also are in places in interstellar space. So if you have these building blocks, what is the likelihood that maybe they came together on another planet? So we need to think about, if we want to think about things like us, we can think about what makes life on Earth possible. And one of the biggest things is our location in the solar system. And that is that we live in the Goldilocks zone. So if you've ever read the story of Goldilocks and the Three Bears, you know that she was eating some porridge and some of the porridge was too hot, some of the porridge was too cold, and she wanted the porridge that was just right. Yes, we are in fact stardust. When we talked about stars dying that make neutron stars and stuff, heavy elements like iron that's in our blood or calcium that's in our bones, those elements are actually made, and when those stars collapse and explode, those different elements get thrown out into the universe from these stellar explosions. So yeah, stuff that gets made in the hearts of stars make up elements that we have in our bodies, like the calcium and the iron and everything like that. So thinking back to Goldilocks and the Three Bears, stars also have Goldilocks zones or habitable zones, where you have regions that are too hot, too close to the star, You have regions that are too cold and far away from the star. And then you have regions that are just right, that are the right distance away, that if there's water on the surface of those planets, that it can live in a liquid form that we can use. So talking about the Goldilocks zone, and that's what Earth likes. Do you guys think that there are any exceptions to the Goldilocks zone? Are there any possible places, thinking about our own solar system, where things could maybe be alive? I see a maybe. I see a Mars. So we're going to say yes. And the caveat to that is if there is another source of energy to keep the object or the moon warm. And so one of those examples is actually a moon of Jupiter called Europa. And it is the 6th largest moon in the solar system, but it's actually the smallest of the Galilean satellites. And if we think about Europa's surface, it's thought to have a solid core, a rocky interior, but then it has a layer of water where it has this crusty ice on top, and it either has warmer ice underneath or it has a liquid ocean underneath. And so if there's water, we like to think there could possibly be life. So Europa is a place that potentially could be somewhere else in the universe that has life available. And then, so I saw a question about if we put it in the Goldilocks zone, could life begin on it? That's a really good question because Mars is actually just on the edge of our Goldilocks zone. And so Mars, which somebody mentioned, is another potential place that there could have been, or maybe could be, life. And there are ideas that in the past, Mars actually had a more significant atmosphere and had liquid water on its surface. Right now, Mars has a very thin atmosphere of carbon dioxide and not standing liquid water. So moving to Mars. If Mars were a little closer to Earth, would Mars have life? It would depend. So we think about Earth, one of the things, we have a very strong magnetic field that protects us from radiation, and we have liquid water. So if Mars had those things and was closer, maybe. We don't actually know why Mars looks the way that it does today. Because we do know though, that it had some kind of interesting past because it has the largest volcano that we know of in the solar system. So Olympus Mons here, and a bunch of other volcanoes. So it was geologically active at some point. And we also see evidence for things like in the past, this looks like a dried up riverbed. And there's also evidence of briny flows where salt water has flowed on the surface of Mars in the very recent future, or not recent future, the very recent past. So potentially, maybe there was water very recently that we could see, but we don't know. And there are also ancient Martian rocks that were found on Earth that seem to have evidence of microorganisms. So maybe those came from Mars and they were from Mars, but luckily we have a bunch of robots on Mars doing really good science, getting a lot of good data and sending it back to scientists on Earth to try to understand why Mars looks the way that it does today. And if potentially there's something still there. Yeah.
Lots of good questions in the chat here. So people asking if the Goldilocks zone was moving backward, wouldn't it have been colder in the past? Kind of. So this is what we were talking about earlier with how the sun is getting hotter slowly. If the sun gets hotter, that Goldilocks zone where you can have water kind of grows and moves out a little bit. And so it does move, but this is very, very slowly. So this shouldn't have a big impact on the planets themselves over the timescales that we're talking about here, just because these stars are evolving and changing that brightness so slowly.
Yeah, that's a really good point. What is in Mars? Robots. There are lots of robots from Earth on Mars. Although I will say historically, Mars does not appreciate it when we send robots to it. And a little under half of all the missions that we've tried to send to Mars have not been successful. But in the recent future, or why do I keep saying recent future? In the recent past, like very recently, we've had very good luck getting robots on the surface. So yeah, happy little rovers and Ingenuity, a little helicopter running around. Yeah, so Mars had water years ago. So we see that in these briny flows, and we see that in these dried up riverbeds. Also, the temperature of Mars in the Martian summer around the equator can be like 60 degrees. So Mars isn't quite, I mean, it does get very cold, don't get me wrong, but Mars does have, almost comfortable temperatures at its equator during the summer. Yeah. Yes, we've sent quite the collection of robots to Mars, and they're all doing really great things. So to wrap up and to kind of lead into our final activity that will send you guys home with, what do you guys think are the odds that there's life elsewhere in the universe? Well, let's look at some math and some numbers. So we think about our own galaxy, the Milky Way. There are hundreds of billions of stars living in this galaxy. So the likelihood that one of those stars has a Goldilocks zone where a planet like Earth lives seems pretty good. And if we look at this little plot here, I couldn't find anything newer than this one from 2017, but we have the majority of the planets that we find are somewhere between the size of Earth and Neptune. Excuse me. And Neptune is about 4 times the radius, or excuse me, the diameter of Earth. So if you were to line them up, you could fit 4 Earths across the middle of Neptune. And then you have planets that are like Jupiter up here. So maybe on this collection of planets that are somewhere in between Neptunes and Earths, perhaps. And then thinking about, our neck of the woods where we're on Earth in the solar system, in our own little neighborhood of stars, in our own galaxy. There are also so many galaxies in the universe where you have the local group, and then our supercluster, and then all of the superclusters, and then the entire observable universe. So with all of that, with there being so many galaxies and so many stars and so many planets, what do you guys think is out there? I personally hope that it is space cats. That would make me very, very happy. So with that, we're going to talk a little bit about the creating your own alien activity that we gave to you guys. So let me go ahead and close out this presentation. Save. As you can see, I am a fan of space cats. And then you have your create your own alien activity. So with this, you can use whatever craft materials you have at home. You can draw, if you have paint or pipe cleaners or cardboard or clay, whatever you have at your house to do craft activities, you can use that. If you draw on iPads, you could totally use that too. And so to do this, we gave you a set of exoplanets, so different planets to think about. So the first exoplanet is a planet that's more massive than Earth, which has a stronger gravity. I agree, there probably aren't any space cats, but I do wish that there were, because they're very cute.
We do have a suggestion for space dogs as well.
That would also be very cute. And then you have planets that are less massive. So with these first 2 planets, gravity would be different. How do you think gravity would affect a creature living on that planet if they had heavier gravity that was pulling harder, or lighter gravity that was pulling less? Then you have liquid planets, you have gas planets, icy planets, planets with carbon dioxide atmospheres and dust storms and dormant volcanoes. That might be similar to a planet that we just discussed a little bit ago. Planets that have more than one star, because Andrew studies this, you study multiplicity a little bit, don't you?
A little bit, yeah.
Yeah. So it's not uncommon for stars to have companions, where they have one other star or a couple of other stars that all live together. Then you have a planet that's tidally locked to its star, just like the moon is tidally locked to the Earth, where it always shows the same face because it's rotating at the same rate that it's revolving. And so thinking about picking one of these exoplanets and the type of planet you want to make, you then can think about what your alien's body would look like, what the alien would use for food or energy, because we agreed that that is something that things that are alive need, how they get around based on what the planet is like, what features or abilities they have, and what aliens. And yeah, and you can do this more than once. You could do this a very cool. It's very fun, and especially when the weather is kind of crummy outside, it's a really fun activity to do in your home. So let me go ahead and stop sharing. And
So we had a question about, can we send cats in a
actually,
spaceship?
there
We
was
have.
yes, Phyllisette, I think was the cat's name.
Yes.
It actually has a statue because it was the first cat to go to space. I think the statue was in France. Yeah.
Yes, it was part of the French space program. I posted a link in the chat for everyone if you're curious. So this was a stray cat that they sent on a spaceship up into space. And then we have also sent dogs as well.
Mm-hmm.
So I also created a Qualtrics survey if people want to create their alien and then share it with us. And I would love it if we could get some entries there. So I'm going to share the link in the chat window in just a moment. And also we have another survey from the organizers of the Atlanta Science Festival that I'll also share in the chat window. And so we really appreciate everybody coming and joining us today, and we would love your feedback and love to see your alien creations, and hope you have fun also exploring the night sky tonight. So thanks, that's what I wanted to say.
Yeah. So we'll go ahead and post those links in the chat. Thank you all for participating and talking with us so much. This has been so much fun, and I hope that you make some cool aliens. And like I said, if you, like Dr. Connor said, if you can share them with us to one of the links, we would love to see them. And I hope that it clears up so you guys can have good star viewing outside. And yeah, thank you all so much. And we'll go ahead and post the links. And so one of them, as Dr. Connor said, was for you can potentially win a gift card for the whole science festival. And then the other link is for you all to post your images of your aliens that you make and share them with us so we can see them. So again, thank you all so much. And it was wonderful spending part of the morning with you, and take care and enjoy the rest of the festival.